Now, so far we've looked at Newton's first law, which says that objects in motion tend to stay in motion and objects at rest tend to stay at rest unless acted on by a net force. We've also seen that a net force is the same thing as an unbalanced force, and if an unbalanced force acts on an object, it will accelerate. So now we're going to look at Newton's second law, which looks at the net force and its relationship to mass and acceleration. So let's start by looking at a basic simulation where we can apply a force to a mass and we won't worry about friction. So we see on the simulation that I'm going to put this crate of mass 50 kilograms on a frictionless surface, and the frictionless surface is provided by our skateboard. And I'm going to apply a force to this crate. And we want to see what happens to the motion of the crate. To do this, I'm going to put a little speedometer at the top, and we can watch how its speed changes as I apply a force. So I'll start with a gentle force, very, very little, and you can see our speedometer is gradually increasing, it's accelerating. If the force is bigger, it accelerates much more rapidly. And if I reduce the force and flip it in the other direction, in fact, I slow the object back down to 0 until it stops, changes direction, and starts going in reverse. So nothing unusual about this. What we want to do is describe how the acceleration depends on the mass. So let's look at a few extremes. Let's start with a fairly light mass. Now you can see they're all listed below. So let's maybe start with our 10 kilogram mass here. And we want to be consistent. So we're going to have a consistent 10 Newton force acting on this object. So we'll start by putting our speedometer at the top. And let's put a 10 Newton force down at the bottom. And once I hit go, watch how long it takes for the speedometer to reach the 12 o'clock mark. And you can just use your clock that's on your YouTube video on the lower left. Let's check it out. So we can see it's gradually increasing speed, very, very slowly, picking up speed, until finally it reaches our desired level right now. Now let's see what happens when I use a much heavier object. So you saw how long that took. It accelerated, but it took a long time to get up to that set speed. So now we've got a 200 kilogram mass. Same force, 10 newtons, and when I run it, notice that it just barely starts to accelerate. In fact, we may not even be able to wait this thing out. It might just take too long for it to reach that 12 o'clock magic mark. But it clearly is still accelerating. The speed is still increasing. Remember, acceleration is the rate of change of velocity. So as long as we're speeding up, we are definitely accelerating. But here we see one of the relationships in Newton's second law. And that is, as the mass gets larger, the acceleration gets smaller, which is a very predictable result. Now the other relationship is the net force relationship, and let's look at that. So to test this relationship, let's keep the mass constant. I'll use this garbage can, 50 kilogram mass. And once again, we'll start with a 10 Newton force, and we'll run it and see how long it takes for the speedometer to reach that 12 o'clock mark as it speeds up. So again, watch your time on your YouTube video, and we'll see how long it takes to get to the 12 o'clock mark at the top with a 10 Newton force. It's almost there, getting faster and faster. Notice that the speedometer's rate of change of speed is consistent all the way through. And that's because it's got a consistent acceleration. Okay, we're almost there now. Okay, now we'll reset. Show our speedometer. Same object. This time we'll put a 20 Newton force on the skateboard itself. Okay, we'll see how long it takes. And you can see that the hand is sweeping much more rapidly to the 12 o'clock mark. It's speeding up much more rapidly, a greater acceleration. In fact, it's twice the acceleration. There, we can stop. So as the applied force gets larger, as the net force gets larger, your acceleration also gets larger. So that's Newton's second law. One relates acceleration and mass, and we see an inverse relationship. And one relates acceleration and net force, and we see a direct relationship. The equation is very simple. It simply says that F net is mass times acceleration.